We have to find the range of g, and if I can actually use my graphing calculator, what we'll do is we'll definitely try to plot the graph of gx and then find the y coordinates of the maximum point and the minimum point here. That means the range of g is from minus infinity to the y value here, and then from the y value here to positive infinity. But unfortunately, this question requires us to find the range of g but using an algebraic method. And that is why this graph that is here is solely for our visualization, because we cannot produce this into our solution. But what we are going to do is, on top of this graph, what I'm going to come up with is a horizontal line y is equal to k. And I want to make sure that this horizontal line is going to cut the curve. Because whenever this horizontal line cuts the curve, it is where the graph of gx exists, and that will actually give us the range of values of g, if I can actually find a range of values of k such that this line and the curve intersects. So algebraically, this is what I'm going to do. I'm going to let y be equal to gx, so this 1 minus x squared, and I'm also going to let y be equal to k. And I'm going to try to solve a pair of simultaneous equation here, and this pair of simultaneous equation, because I want this line and this curve to intersect, the simultaneous equation should give me a solution. So let's see what we are going to get. So 2 plus x, 1 minus x squared, this is equal to k. And if I were to cross multiply, 2 plus x is going to be k minus kx squared. Bring everything over to one side. I have kx squared plus x plus 2 minus k is equal to 0. And because this line and this curve, they are supposed to intersect, which means that for this quadratic equation that I have here, it is supposed to have solution, which means that I'm going to let the discriminant be bigger or equal to 0. And the discriminant is b squared minus 4ac. This is bigger or equal to 0. So what I have here is 4k squared minus 8k plus 1 is bigger or equal to 0. That means k squared minus 2k plus 1 over 4 is bigger or equal to 0. And I'm going to complete the square for this. Completing the square for this is k minus 1 square minus 3 over 4 is bigger or equal to 0. Now I can rewrite this as k minus 1 square minus this is square root of 3 over 2 square is bigger or equal to 0, which means that k minus 1 minus square root of 3 over 2 and k minus 1 plus square root of 3 over 2 is bigger or equal to 0. And if I were to draw a number line in terms of k, that means I have 1 minus square root of 3 over 2 and 1 plus square root of 3 over 2. It is going to be a plus minus plus here, and I want the region that is bigger or equal to 0. That means I want this region and this region. So k is supposed to be less than or equal to 1 minus square root of 3 over 2, or k is supposed to be bigger or equal to 1 plus square root of 3 over 2. And what is k? K is y, which means that y is less than or equal to 1 minus square root of 3 over 2, and then y is also bigger or equal to 1 plus square root of 3 over 2, which means that the y coordinates of these 2 points is actually these 2 values, but now we managed to work this out algebraically. That is why with these 2 values that I have here, I can find the range of g, which is from minus infinity to 1 minus square root of 3 over 2, including this point, or from 1 plus square root of 3 over 2 to positive infinity.